Good morning, good afternoon, good evening, all of you. So today we are here to learn about Kubernetes. Kubernetes is one of the most famous orchestration tool that is used in the industry. So first let's understand what is this Kubernetes and why we need to learn this Kubernetes and where we are going to use this Kubernetes software. First of all, Kubernetes is also called as K8s. So some people will call it as K8s, some people will call it as Kubernetes. K8s nothing but between K and S, there are 8 characters available. That is the reason people will call this as Kubernetes. Kubernetes is an open source orchestration platform. What is the meaning of open source orchestration platform? You no need to pay the money to use the Kubernetes. Kubernetes is free of cost. Kubernetes is free of cost and open source. And it is called as orchestration platform. Orchestration is nothing but management, guys. So in the last few days back, we discussed about Docker. Docker is called as containerization software. Kubernetes is called as orchestration software. Orchestration is nothing but management. So instead of we are creating containers for the application, instead of we are scaling up the containers, scaling down the containers, we can use Kubernetes to manage our Docker containers. So nowadays, every application is getting deployed by using Docker. Docker we are using to containerize the application. Here, whatever the containers you want to create, the containers management we can do by using Kubernetes. That is the reason it is called orchestration platform. In the simple terminology, orchestration is nothing but management. It is used to manage our Docker containers, guys. Fine. So here, this Kubernetes software we are using to manage our container. Container means container is a box where we are going to run our application. This Kubernetes software developed by Google. Google company developed this Kubernetes software and later they donated to other organization. CNCF organization is available. Google developed this Kubernetes software and they donated to CNCF organization. And what we can do by using this Kubernetes? This Kubernetes software provided a framework. Kubernetes provided a framework which is used to manage complex tasks related to application deployment, application containers scaling, application deployment by using containers. Okay, scale up the containers, scale down the containers, like the deployment complete, application deployment process will be taken care by Kubernetes. So in the real time, application deployment process will be taken care by DevOps team, right? So the DevOps team is going to use this Kubernetes software to manage application deployment. So that is the reason Kubernetes is called as one of the most famous DevOps tool in the market. So developers and DevOps people should know what is this Kubernetes and how to work with the Kubernetes. Without asking the questions on the Kubernetes, the DevOps interview will not be completed. And nowadays, in every interview for the developers also, they are asking questions related to Kubernetes because this is very powerful software to manage our application deployment process. Docker will be available. Kubernetes also will be available in order to deploy our application. I want to run my application. Okay, currently people are following microservices architecture to develop the application. In the microservices architecture, front-end application will be available, back-end microservices will be available. 10, 20, 30, 40 like that. Multiple back-end microservices will be available. Every microservice we are going to deploy as a separate container. So like this, in one project, multiple containers will be available. So all these are Docker containers. All these are Docker containers. For example, I have 50 microservices in my application. So if I want to deploy those 50 microservices, then 50 containers I have to create. And for one microservice, I want to do the load balancing. Instead of running my microservice in one Docker container, I want to run my microservices in 20 Docker containers for the load balance. So here, if you want to create the containers, if you want to manage the load by using containers, that will become very difficult process. So that's why in order to manage our containers, we are going to use orchestration platform. That's where Kubernetes comes into picture. Kubernetes is called as orchestration platform. So could you please respond in the chat box? Are you clear? What is Kubernetes? Why people will use Kubernetes in the market? Are you guys clear what is Kubernetes? Why people are going to use Kubernetes? Kubernetes is called as orchestration platform. What is the meaning of orchestration? Orchestration is nothing but management. Orchestration nothing but management. It is used to manage Docker containers. What is a Docker container? Container is nothing but a box where our application deployment will happen. Container is a box where our application will be executed. So for one application, multiple containers will be available in the real time. So one application we are going to deploy by using multiple containers to manage the load. Suppose if I am having multiple microservices, for every microservice, I want to create multiple Docker containers. So instead of we are creating the Docker containers manually, we are going to use Kubernetes in order to create the containers and in order to manage the containers. Okay, developers should know how to work with this Docker and Kubernetes. DevOps people also should know how to work with this Docker and Kubernetes. All right, next one. So if you see application architecture, I'm taking one microservices based application. Microservices, one of the most famous architectural design pattern to develop the projects. Earlier, people used to develop the project by using monolithic architecture. Monolithic architecture, nothing but everything will be developed in the single project. Everything will be developed in the single project and a single container will be created to deploy the application. But today, in the today's market, monolithic architecture got outdated. People are going for microservices architecture. I'm taking a simple example of e-commerce application. If you go for this e-commerce application, product service available, order service available, customer service available, payment service available, cart service available, wishlist service is available. So like this, multiple services available in our microservices architecture. Okay, now for every microservice, separate database is also available. This concept is called DB per service concept. So every microservice is a separate project which will run in the separate server, and for every microservice, separate database is also available. Now I want to deploy this application. Okay, to deploy this application, we are going to use Docker containers. Now, for this product service, I need to create one Docker container. For order service, I need to create one Docker container. For customer service, I need to create one Docker container. Like this, for every microservice, we need to create the Docker containers in order to run our application. Docker is used as containerization software, which is used to run our application in any machine. Now, for example, for other service, so many requests are coming. So one server I am using to run the application. That means one server, nothing but one container. Other service is currently running in one container. If other service is running in one container, that cannot handle the load, because today there is a big billion day offer available in our application. Lakhs of customers are placing the orders in the e-commerce project. When the lakhs of customers are accessing our application, then one container is not sufficient to handle that load. Then what we need to do, instead of running our application, our microservice in one Docker container, I want to run my application in multiple Docker containers. I want to create 20 Docker containers. If so many requests are coming, I want to increase the containers. If a more number of requests are coming, I want to increase the containers. If less number of requests are coming, I want to decrease the containers. So if any container is crashed, then I want to replace that with the another container. So like that, lot of management operations are required on the Docker containers. So to manage these Docker containers manually, it will take a lot of time and it is a risk also. That is the reason we need to automate our containers management functionality. To automate that containers management functionality, orchestration tools will be used in the market. Kubernetes is one of the orchestration tool which is used to manage the Docker containers of our application. Are you able to understand? What is the problem when you are going for application with microservices architecture? Multiple microservices will be available for one project. For every microservice, we need to create a Docker container. And one Docker container is not sufficient. Multiple Docker containers we need to create for one microservice. For example, for order microservice, I created one Docker container. So with one Docker container, one server will be available to handle the request. If more number of requests are coming, then one container is not sufficient to handle the load. Then we need multiple containers. So creating multiple containers, increasing the count of the containers, decreasing the count of the containers is called management. That management work will be taken care by Kubernetes. So what are the benefits we are going to get with the Kubernetes? There are several benefits available with the Kubernetes. Before going to understand, are you clear why we are using Kubernetes in the market? Are you guys clear with my point? Why we are using Kubernetes in the market? It is used to manage containers, like create the containers, delete the containers, scale up the containers, scale down the containers. Complete containers management will be taken care by Kubernetes software. Kubernetes is called as orchestration platform. Docker is called as containerization platform. What are the advantages we are going to get with this Kubernetes? Okay, what is the first advantage with the Kubernetes? The first advantage with the Kubernetes, it is providing a platform to manage the containers. That is called container orchestration. Kubernetes is used to orchestrate our containers. So the best thing that with the Kubernetes is it is used for container orchestration purpose. Then what is the second advantage with the Kubernetes? Scalability. Scalability nothing but based on the demand, it can increase our containers or it can decrease our containers. If more number of requests are coming, then containers count should be increased. If less number of requests are coming, then containers count should be decreased. That means it has to adjust the infrastructure capacity. It has to adjust the infrastructure capacity based on the demand. It has to adjust the capacity based on the demand. That is called scalability. That is called scalability. Suppose, for example, today my application is running in one container, but so many users are accessing my application. When multiple users are accessing our application, one container is not sufficient to handle the load. Then we need to create multiple containers in order to handle the load. Then we need to increase the containers. If more number of requests are coming, containers count should be increased. If less number of requests are coming, then we need to decrease the containers. That is called scalability. Kubernetes will take care of that scalability. Next one, self-healing is the another advantage we have with the Kubernetes. So what is the meaning of that? Self-healing. Self-healing nothing but if any container is damaged. For example, I'm running my application in two containers. One of the container got damaged. That means due to some problem, that container got stopped. If the container is stopped, then our application will be down. So to resolve that problem, Kubernetes will perform self-healing. Nothing but if any container is damaged, Kubernetes replace that and will with the another container. Kubernetes will replace that with the another container. So that is self-healing capability. If anything is damaged, it will create another container in that place. That is called self-healing. And the next one, load balancing. So here, when our application is running in multiple containers, it will distribute the load to all the containers in the round robin fashion. Instead of sending all the requests to single container, Kubernetes is going to take care of this load balancing concept. So these are the advantages available when we go for Kubernetes concept. Kubernetes is providing container orchestration platform, and it is providing scalability. It is providing self-healing capability, and it is taking care of load balancing also. Are you guys clear? So just summary, orchestration platform, it is used to manage the containers. It is providing a platform to manage your application deployment, your application scalability, your application load balancing. Now, this Kubernetes software developed by Google company and they donated to another organization. So if you want to work with Kubernetes, then you should know the Kubernetes architecture. Very, very, very important concept. Kubernetes architecture. Kubernetes works based on cluster architecture. Kubernetes works based on cluster architecture. So can anyone tell me what is the meaning of a cluster? Do you know what is a cluster? Any idea? What is the meaning of cluster? Any idea? Come on. What is the meaning of cluster? Do you have any idea? Cluster is nothing but group of servers. Cluster is nothing but group of servers. Kubernetes works based on cluster architecture. What is the meaning of cluster? Cluster means group of servers. So if you want to use Kubernetes, then you need multiple servers. If you want to use Kubernetes, then you need multiple servers. With one computer, you can't set up the Kubernetes. So group of computers required, then we are going to set up the Kubernetes. Kubernetes works based on cluster architecture. Cluster nothing but group of servers. Let us see the Kubernetes architecture diagram. This is the Kubernetes architecture diagram. Just read all the components which are available in the architecture. Then we will understand how to work with this, and we will do postmortem on this architecture, guys. Before we are going to understand, just have a look about the architecture and see that. This is Kubernetes cluster architecture. This is called Kubernetes HA architecture, high availability architecture. This is called as Kubernetes high availability architecture. Just look at this. Just look at this. What is this? What are the components available? Control plane is available and worker nodes available. Inside the control plane, API server available, scheduler is available, controller manager, etc. Inside the worker node, pods available, containers available, Docker available, kubelet is available, kube proxy available. Okay, right. And user interface is available to connect with the control plane, and kubectl is available to connect with the control plane. If you see in the Kubernetes architecture, the first important thing that is a control plane. Control plane is like a manager for the team. Control plane is like a manager for the team. Control plane is going to manage the team members. The team members nothing but worker nodes. Worker nodes are called as team members here. Control plane is also called as master node. So in the Kubernetes, control plane is also called as master node, which will manage everything in the Kubernetes. Okay. If you want to deploy your application, then you need to inform to the control plane. Whatever you want to perform in the Kubernetes, whatever the task that you want to do by using Kubernetes, that a task you will give to the control plane. Control plane is also called as master node in the Kubernetes. Inside the control plane, API server available, scheduler is available, controller manager is available, and etcd is also available. API server, scheduler, controller manager, and etcd. We'll talk about that. As of now, what is the meaning of control node? Control plane. Control plane is nothing but master node, which will manage everything in the Kubernetes. Okay, guys. Next up, this control plane will be connected with the worker nodes. Worker nodes nothing but the machines in which our application will execute. Worker nodes are nothing but employees. Control plane is nothing but manager. So whenever a task comes, whenever a requirement comes, that requirement will go to control plane. Then control plane will assign the task to the worker node. Inside the worker node, our application will be executed as a container. That container will be created inside the pod. In the Docker, Directly we can create the container, but in the Kubernetes, we are going to create the pods. Pod is nothing but a process. Pod is nothing but a process. So whatever the application that you want to execute, for that application, pod will be created in the Kubernetes. Pod is nothing but a process. Inside the pod, our containers will be created. Inside one pod, you can create multiple containers also. Okay, so you can create multiple pods. Suppose I want to run my application in multiple servers. Then multiple servers, nothing but multiple pods we are going to create. So here inside the Kubernetes architecture, one control plane can have multiple worker nodes also. So for a high availability, worker node 1, worker node 2, I'm taking. So whenever you deploy your application, for your application, pods will be created inside the worker node. Inside the worker node pod, inside the pod, container will be available, and Docker engine will be available, kubelet will be available, and kube proxy will be available in the worker nodes. Now, I want to deploy my application. So to deploy one application, Docker image is required. First, we need to create Docker image for the application. By using that Docker image, we will create the pods in the Kubernetes. Inside the pod, container will be created. That means as a programmer or as a DevOps engineer, I need to tell to the control plane to deploy my application in the Kubernetes cluster. That means we need to communicate with the control plane. In order to communicate with the control plane, there are two ways available. By using UI page also, by using UI pages, you can communicate with the control plane. That will give you a graphical user interface in order to communicate with the Kubernetes control plane. If you don't want to use graphical user interface, then you can use kubectl, kubectl. People will call it as a kubectl. Some people will call it as a kubectl. Some people will call it as a kubectl. Kubectl is a command line utility which is used to communicate with the Kubernetes control plane. For example, I want to deploy my application in the Kubernetes cluster. To deploy our application in the Kubernetes cluster, we can use kubectl software. By using kubectl software, we can communicate with the control plane. Then control plane will communicate with the worker nodes in order to complete the task. I have a Docker image for my Java application. By using that Docker image, I want to create containers. So here we are going to give that information to the control plane. Then control plane will give the information to the worker node. Inside the worker node, our application will be deployed by using a concept called pod. By using a concept called pod concept. Are you guys able to understand? Are you able to understand? Kubernetes control plane and worker nodes and kubectl. So Kubernetes works based on cluster architecture. So in the Kubernetes cluster, group of servers will be available. What are the main things here? One is control node. Control node is also called as master node. Control node or control plane. People will call it as control node or control plane, or we can call as master node. And the second thing, worker nodes. Okay, multiple worker nodes will be available. And the third one is kubectl. Okay, what is the control plane in the Kubernetes, which will manage the works in the Kubernetes cluster? So whatever the task that we are giving, that a task will be given to the control plane by using kubectl. What is this kubectl? Kubectl is a command line utility which is used to communicate with the control plane. Kubectl is a command line utility which is used to communicate with the control plane. Okay, so inside the control plane, what is available? Inside the control plane, API server is available, scheduler is available, controller manager is available, and etcd is available. Etcd is available. Now, let's understand them one by one. Okay, first thing is control plane. So Kubernetes control plane will contain API server, scheduler, controller manager, etcd. When we talk about Kubernetes architecture, we need to talk about control plane. Inside the control plane, what is available? Inside the control plane, API server available, scheduler is available, controller manager is available, and etcd is available. Coming to the worker node. So what is a worker node? Worker node means which will perform the task based on the instruction given by the control plane. So I will give instruction to control plane. Control plane will give the instruction to the worker node. Inside the worker node, our application will be executed as a pod. So what is available inside the worker node? Inside the worker node, pod will be available, containers will be available, Docker engine will be available, kubelet will be available, kube proxy will be available. So inside the Kubernetes worker node, we have pods and we have containers, we have Docker engine, we have kubelet, and we have kube proxy. Now, how to deploy our application in the Kubernetes cluster now? Kubernetes is a deployment software, right? Which is used to deploy our application, which is used to create the containers for our application, which is used to manage our containers. So we need to give some instruction to the Kubernetes to perform the operation. For example, I want to deploy my application in the 10 containers. I need to give the information to Kubernetes. For example, I want to delete my application from the Kubernetes. I want to undeploy my application. I want to increase the pods. I want to decrease the pods. I want to do the scaling. I want to scale up. I want to scale down. So that framework is available. Kubernetes is providing the framework to manage our application deployment, scale up, scale down, auto scaling, load balancing, self-healing. All these things we are getting. But we need to give some instruction to the Kubernetes to perform the deployment. To give the instruction to the Kubernetes, we need to communicate with the control plane. In order to communicate with the control plane, there are two ways available. By using web dashboard, you can communicate with the Kubernetes control plane by using kubectl, CLI command also. By using commands also, you can communicate with the Kubernetes. By using web dashboard, you can communicate with the Kubernetes, or by using kubectl also, you can communicate with the Kubernetes cluster. So these are the three important things that we need to understand before getting into Kubernetes architecture internals. Kubernetes works based on the cluster architecture. Cluster is nothing but group of servers. In the Kubernetes, control plane will be available and worker nodes will be available. Control plane is called as master node. Control plane is called as master node. And worker nodes will be available. Whatever the deployment we need to do, the instruction we will give to the control plane will give the instruction to the worker node. Inside the worker node, our application will be executed as a pod. How can we communicate with the Kubernetes cluster as a DevOps engineer or as a programmer? That's where you can use a web dashboard to communicate with the control plane, or you can use kubectl to communicate with the control plane. All right. Now we need to understand the internals of this Kubernetes cluster architecture. Okay. So first one is control plane, guys. So inside the control plane, we are having schedulers, right? Inside the control plane, we have API server, we have scheduler, we have controller manager, and we have etcd. So let's talk about Kubernetes architecture components. Let's talk about Kubernetes architecture components. All right. Kubernetes architecture components. What is the first component in the Kubernetes architecture? Control plane. Inside the control plane, API server is available. Sir, what is this API server? API server will take our request. Now, I want to deploy my application in the Kubernetes. By using web dashboard or by using kubectl, I will tell to Kubernetes, hey Kubernetes, deploy my Python application. So this is the Docker image of my Python application. Please deploy that application in the Kubernetes. Like this, as a programmer, as a DevOps engineer, I will send request to the control plane. When I send the request to the control plane, then inside the control plane, there is a component called API server. API server will receive incoming request and it will store that request information into etcd. Okay, if you see this architecture, API server is available and etcd is available. Whatever the request I'm sending by using kubectl to the Kubernetes cluster, that control plane, API server will take my request. Okay, whatever the request I sent, request nothing but deploy the application or increase the containers of the application, decrease the containers of the application, delete the application from the Kubernetes. These are called requests to the Kubernetes. So I will send a request to run my application in the cluster. When I send that request, then API server in the control plane will receive our request and will store our request into etcd. Okay, what is this etcd in the Kubernetes? Etcd is the internal database for the Kubernetes cluster, which is used to store the request information. What request we have sent to the Kubernetes cluster, what request received by the API server, all the request information will be maintained in one database in the Kubernetes that is called etcd. etcd is Kubernetes cluster database, that is internal database for the cluster, which is used to maintain all the request information. Okay, I sent a request to deploy my Python application. API server received my request and it stored that request into etcd database. Once that is stored in the etcd database, then scheduler will come into picture. Scheduler is responsible to schedule the pending tasks available in the etcd. Whatever the request comes, that will go to API server. API server will store in the etcd. Then scheduler will come into picture. It will check what are the pending tasks available in the etcd. Then it will take those pending tasks and it will schedule the pending task to the worker nodes. Okay, I want to deploy my application. That task is still pending. So it is available in the etcd. So then scheduler comes into picture. Scheduler will check pending tasks in the etcd and it will schedule those tasks in the worker nodes. Okay, so this person asked you to deploy one Python application. Okay, so then scheduler will check that request is still pending in the etcd. Then scheduler will communicate with the worker nodes. Scheduler will check how many worker nodes are available, how many are up and running. So there are 2 worker nodes available, worker node 1 and worker node 2. Out of these 2 worker nodes, which worker node is free? Suppose simple. When client gave some requirement, manager will check which team member is available. Then manager will assign that task to the team member. Then team member will do the actual task. Manager will take the task from the higher authority or from the client. Manager will assign the task to the team members. Team members will complete the task. Same concept here also. When we send a request, control plane will take it. Then it will assign to the worker node. Okay. So here the request will be received by API server. Then it will store that request in the etcd. Then scheduler comes into picture. Scheduler will check which worker node is available to do this task. Then it will assign the task to that particular worker node. In that worker node, our application will be deployed as a pod. Worker node is nothing but a slave. Master and slave. Control plane is called as master and worker node is called as a slave. Worker node is called as slave. Okay. Then what is kubectl? Can you guys tell me what is kubectl in the Kubernetes? A software to communicate with the Kubernetes cluster. A command line interface which is used to communicate with the Kubernetes cluster. Okay. What is API server? Come on. What is API server in the Kubernetes? It is going to receive the request in the control plane. Then what is etcd? What is etcd? etcd is a Kubernetes cluster database. Then what is the scheduler in the Kubernetes cluster? What is the scheduler in the Kubernetes cluster? It will check what all the pending tasks available and it will assign the pending tasks to the worker nodes. Okay, here guys, scheduler will get the available worker nodes information because inside this cluster, inside one team, multiple team members will be available. One manager, multiple team members will be available, right? So which team member is free? For which team member we need to assign this task? That will be taken care by scheduler. How scheduler will understand to which team member we need to assign this task? That's where here there is a concept called kubelet, guys. Can you see the concept here? Kubelet. Kubelet is called as personal assistant for the worker. Is called as a node agent. Scheduler will get the available worker nodes information by using a node agent which is called kubelet. API server will receive the request, will store in the etcd. Etcd is a cluster database. Scheduler will check pending tasks in the etcd and will schedule those tasks in the worker nodes. How the scheduler will know in which worker node it has to schedule the task? Then scheduler will get the available worker nodes information by using kubelet. What is the kubelet in the worker node? Kubelet is like a PA, personal assistant. Okay. So PA, suppose if you take any celebrity or any politician, the personal assistant will be available for them. They will manage their schedules. Okay. Suppose if you want to connect with any celebrity, first you need to check the celebrity availability by talking to his PA. Then PA will tell the schedule, when he is available, at what time he will give the appointment for you, all that information. Same concept here. For every worker node, a agent will be available. That agent is called as kubelet. Kubelet is called as worker node agent. By communicating with the kubelet, we will understand the health of the worker node, status of the worker node, whether that worker node is available or not, what pods are running in the worker node. All that information we can get by using kubelet. So here, scheduler is going to communicate with the worker node using this kubelet. Then based on the availability, scheduler will assign the task to the worker node. Okay. Then, so here, scheduler should communicate with the worker node. Worker node should communicate with the control plane, should communicate with the worker node. Worker node should communicate with the control plane. Control plane is one machine. Worker nodes are other machines. So total 3 machines available here. Group of machines, that is called cluster. So this control plane machine should communicate with the worker node machine. Worker node machine should communicate with the control plane machine. So there should be some network communication. There should be some network communication. So to establish this network communication, kube proxy will provide the network. Okay. Kube proxy provides the required network for the communication from control plane to worker node and worker node to the control plane. So that is called kube proxy. Okay. Kube proxy provides network for the cluster communication. So cluster communication means group of servers available. This group of servers should communicate. Suppose for example, your manager is available in the Hyderabad location. You are working from the Bangalore location. How manager will connect with you? Through email or by using Teams chat. He will message you in the Teams chat, or he will set up a meeting with you. He will send an email to you. That is a team communication. Right? So there should be some software for the team's communication in the project. Similarly, for the cluster communication, network is required. That network will be provided by kube proxy. Okay, kubelet is called as worker node agent. Kube proxy will provide the network which is required for our cluster communication. Are you able to understand what is a kubelet and what is a kube proxy? Are you able to understand what is a kubelet and what is a kube proxy? Kubelet is called as worker node agent, and kube proxy will provide the network for the cluster communication. Okay. Then once the communication is done with the kube proxy, scheduler will schedule the task to the worker node. Scheduling the task nothing but application deployment. How the application will be deployed? In the Docker, directly container will be created. In the Kubernetes, container will not be created directly. In the Kubernetes, pod will be created. Sir, what is the full form of the pod? There is no full form for the pod, guys. What is the pod? Pod represents running instance of the application. In the Kubernetes, what is pod? Pod is called as smallest building block that we run in the Kubernetes cluster. Pod represents runtime instance of our application. If you are deploying your application in the Kubernetes, nothing but you are creating a pod. Inside the pod, our application will be deployed. Inside the pod, our application will be executed. Okay. etcd is a database. API server will take the request and will store in the etcd. Scheduler will check the pending tasks in the etcd and it will schedule those tasks in the worker nodes. Scheduler will get the worker nodes information by using kubelet. Kubelet is called as a node agent. and cluster communication is required. For that, kube proxy will provide the network. And once the scheduler scheduled the task in the worker node, pod will be created. What is the pod? Pod is very important thing in the Kubernetes. In the Kubernetes, everything will be represented as a pod only. Pod is the smallest building block that we can run in the Kubernetes cluster. So if you want to deploy your application, you need to create a pod. Pod means smallest building block that we run in the Kubernetes cluster. It represents running application. Pod means our application is running. Inside the pod, you can create multiple containers also. For one application, you can create multiple pods. So here in the Kubernetes, everything will be deployed as a pod. Pod is the smallest building block in the Kubernetes cluster. Inside the pod, our container will be executed. To create the container, Docker image we will use. To run the Docker image, Docker software is required. That's why in the worker nodes, Docker engine will be available, which is used to run the Docker image. When we run the Docker image, Docker container will be created. That a Docker container will be created inside the pod. Okay. Pod means smallest building block that we run in the Kubernetes cluster. It represents runtime instance of our application. If you want to deploy your application, then we need to create the pod. In Kubernetes, our project will be executed as a pod. Inside the pod, containers will be created. To create the container, Docker engine will be used. That is the reason inside the Kubernetes worker nodes, Docker is available. Inside the Kubernetes worker node, Docker is available. Are you able to follow me? What is pod? Pod is the smallest building block that we can run in the Kubernetes cluster. Pod is nothing but smallest building block that is a Kubernetes cluster that is used to run our application. It represents running instance of our application. Sir, I want to deploy my application in the Kubernetes. Then you need to create the pod. Inside the pod, your application will be executed. Okay, then whether pods are created or not, whether the pods are running or not, that the resources, whatever the resources that we have in the Kubernetes cluster, those resources are working as expected or not. Is there any problem for the resources? Is there any issue for the resources? That will be managed by controller manager. In the Kubernetes cluster control plane, controller manager is available. Controller manager will monitor all the Kubernetes resources functionality. What are the resources available? Whether those resources are working as expected or not. Okay. The resources monitoring will be taken care by controller manager in the Kubernetes. That controller manager belongs to control plane. For example, I want to run my application in one pod. Is that pod is running or not? Is that pod created or not? Will be monitored by controller manager. For example, my application is running in one pod. Now I want to run my application in the two pods. So I will tell to Kubernetes to increase one more pod. Whether that pod is increased or not, whether that pod is created or not, will be monitored by control plane in the Kubernetes. That pod is created or not, that pod is running as expected or not, will be monitored by control plane, controller manager. Perfect. Now, sir, how to set up this Kubernetes cluster? I want to go for the Kubernetes cluster set. Kubernetes cluster, we can set up in multiple ways, guys. Now, I want to do the practicals on the Kubernetes. In order to do the practicals, we need to set up the Kubernetes cluster. Kubernetes cluster we can set up in multiple ways. One is self-managed cluster. Another one is provider-managed cluster. Self-managed cluster, nothing but you create your own cluster and you run your application. Suppose I want to take one computer. In that computer, I will install the Kubernetes software. Then I will set up my cluster. Then I will run my application. If you set up the cluster on your own, then that is called as self-managed cluster. For example, I don't want to set up the cluster on my own. I want one ready-made cluster. Then you can go for managed Kubernetes cluster. Managed Kubernetes cluster, nothing but cloud provider will give you ready-made Kubernetes cluster in order to run your application. Okay. So if you want a ready-made cluster, then you can go for managed cluster. Managed cluster means somebody will manage our cluster, then we can use that to run our application. So here there are two things. One is self-managed cluster, another one is managed cluster. In the self-managed cluster also, again there are two types available. One is Minikube, another one is kubectl. Minikube is nothing but single node cluster. Everything, whatever we have seen in the previous diagram, control plane, worker nodes, like this architecture will not be available. Everything will be available in one system only. Then it is called single node cluster. This is single node cluster only for your learning purpose, only for your practice purpose. In the real time, we don't use Minikube for running our applications, guys. Who will use Minikube? Anybody who is a fresher to the Kubernetes, who is starting the Kubernetes learning, first time they are working with the Kubernetes, they want to learn the Kubernetes concepts, then they will go for Minikube. Minikube is a single node cluster that is only for learning purpose. Kubernetes Minikube cluster only for learning purpose. Minikube is called as single node cluster. Okay, only one computer, everything, control plane, worker node, everything will be there in one system. That is called single node cluster. That is not recommended for the real time. In the real time, we need to go for multi-node cluster. Multi-node cluster, nothing but this is the architecture. Multiple machines. Instead of taking one machine, we are going to take multiple machines to run the Kubernetes. That is called multi-node cluster. This multi-node cluster you can set up on your own by using a software called kubectl. kubectl software is available. Sir, what I need to do with the kubectl? You take 3 Linux machines, then you install all these softwares in one machine, then you install all these softwares in the other 2 machines. You take care of everything on your own. That is called kubectl. You install all the required softwares to set up the cluster. That is called multi-node cluster, which you manage on your own. But if you go with the kubectl, you need to manage the cluster. If a cluster is down, then your application will be down. Okay, risk is there when you go for the kubectl cluster, guys. Okay, if your systems are crashed, then your applications will be down. That's why in the real time, people will go for managed cluster, AWS EKS cluster. EKS is a service in the AWS, which is nothing but Elastic Kubernetes service. So I want to run my applications with the help of Kubernetes. That Kubernetes cluster I don't want to set up. I want one ready-made Kubernetes cluster. That's where AWS Cloud is giving EKS service. EKS is one of the most famous and powerful Kubernetes cluster service. If you want to run your applications in the Kubernetes, then go with the AWS EKS. AWS EKS will provide you ready-made platform, ready-made cluster for you. AWS will take care of your cluster. In the AWS, EKS available. In the Azure, AKS available. AKS nothing but Azure Kubernetes service. In the GCP cloud, GKE, Google Kubernetes engine is available. IBM IKE is available. So these all are the managed clusters. Managed clusters nothing but those companies will take care of our cluster. Those companies will give the cluster for rent. Okay. Oracle OKE is available. IBM IKE is available. GCP GKE is available. Azure AKS available. AWS EKS is available. Okay. So in this workshop, I'm going to show you AWS EKS. I'm going to set up my cluster in the AWS by using EKS service in order to run our applications. So that is most famous cluster service in the market. In the real time, which cluster we will use? It depends on which cloud they are using for the project. If they are using AWS cloud, then definitely they will go with the EKS cluster. If any project is using Azure cloud, they will go with the AKS cluster. If they are using GCP cloud, they will go with the GKE cluster. Suppose in my company, cloud is not available, then they will go with the kubectl cluster. It depends on the company, it depends on the project. Okay. In my project, we are using EKS cluster. In my project, we are using EKS cluster, AWS EKS. EKS stands for Elastic Kubernetes service. So we are going to set up a cluster like this in the AWS cloud by using EKS service. Sir, how to set up this cluster in the AWS? What are the prerequisites we need to have to set up the cluster in the AWS? And remember guys, whatever the EKS cluster we are going to set up in the AWS, that is not free, that is a paid service. Kubernetes is free. I'm telling once again, Kubernetes is free, but here EKS is not free. AWS EKS is a paid service. Bill will be generated. Okay, so if you use that cluster for 24 hours, that's negligible. 100 rupees, something like that, bill will be generated. But if you run the cluster for 1 month, then 3,000 to 4,000 rupees bill will be generated. Kubernetes is free. Sir, Kubernetes is free now. Then why we are going to get the bill? Here we are taking provider managed cluster. We are using AWS EKS cluster. We are not setting up the cluster. We are going to use a ready-made cluster. So to give that ready-made cluster, AWS will charge. That is also hourly charges will be available. If you set up EKS cluster, per hour bill will be generated. Okay, so I will show you how to set up the cluster. If you run the cluster for 24 hours, no problem. Very less amount only will be generated. That is negligible. And you no need to pay that bill to the AWS also. I will tell you how to make that bill amount also 0. But after your practice is completed, delete the cluster. Don't keep the cluster in the running state. If you keep the cluster in the running state, hourly bill will be generated. In this class, I will show you how to set up the cluster, how to do the practice, and how to delete the cluster also. We are going to use AWS EKS cluster. If you are using AWS EKS cluster, then Minikube and Kubedium not required. Minikube is only for freshers, guys. That is only for the learning purpose. It is not used in the industry. Kubedium means you need to do lot of setup to set up the Kubedium cluster. That means you need to be strong in the Linux operating system. Then only you can set up the Kubedium. You need to execute around 30 to 40 Linux commands to set up the Kubedium cluster. So if you are comfortable, if you are strong in the Linux operating system, then only you can set up the Kubedium. But in this workshop, there are people who are not from the Linux background. So I don't want to confuse them. That is the reason I am having Kubedium setup document also, but this is 2 days workshop. So that's why I don't want to waste the time. It will take 1 hour to set up the Kubedium cluster. And that too, if you know Linux, then only you will understand. Otherwise, you can't understand the Kubedium. So that is the reason in this workshop, I'm going to use ready-made cluster, which is AWS EKS cluster. How to set up that EKS cluster by using AWS? I have prepared a beautiful document also, guys. Step 1, create EKS host in the AWS. Step 2, create IAM role and attach to the EKS host. And step 3, create EKS cluster using EKS CTL. Then once the setup is completed, we will do the practice. Once our practice is completed, this is the final command which is used to delete the cluster. Okay, so I have prepared one document in the GitHub repository. By following this document, we are going to set up our EKS cluster in the AWS cloud. Let's get started. The first step, create EKS management host in the AWS. EKS management host nothing but I'm going to create one EC2 instance in the AWS cloud. In that EC2 instance, I'm going to install these softwares. kubectl software I will install, AWS CLI software I will install, and EKS CTL software I'm going to install. So the step 1, create one EC2 instance in the AWS cloud. Then install 3 softwares in that machine. One is kubectl, another one is AWS CLI, another one is EKS CTL. Okay, let me go to my AWS account. So currently I logged in into my AWS account. I'm in the Mumbai region. Okay, then go to EC2 and create one EC2 instance. The EC2 instance type I'm taking as Ubuntu Linux flavor I'm taking. That is a Linux distribution. Got it? Now go and launch instance. Go and launch instance. The instance name I'm giving as EKS host VM. The AMI I'm selecting as Ubuntu. Okay, you can select any version of the Ubuntu. I'm selecting Ubuntu Server 22. I'm selecting EC2 instance with AMI Ubuntu. Ubuntu Server 22 I'm taking for that. Instance type T2 micro, that is fine because it is just to execute our commands. T2 micro instance I'm taking. Key pair, if you already have the key pair, then you can select it. If you don't have it, you can create a key pair. I'm taking a key pair name as EKS PEM file. Create key pair. One key pair will be created and it will be downloaded. It is downloaded into our system. Then next, security group SSH traffic will be allowed. Then click on launch instance. Perfect. So with this, my EC2 instance created with Ubuntu AMI. Then connect with this EC2 instance by using SSH client. You can connect with this machine by using git bash or by using mobiextrom or by using putty. I'm going to use git bash in order to connect with this EC2 instance. Now my instance is still pending. Let's wait till it comes to the running state. Now the EC2 instance is started. It is in the running state. Then click on connect option. Here SSH client option is available. Follow this process in order to connect with that machine. Okay, so that PEM file is downloaded. It is in the downloads folder. Now here EKS PEM is available. Let me open my git bash here. Git bash I'm going to use as SSH client. Now, so in this git bash, we need to execute the commands in order to connect with that. First one is chmod command. It is used to give only read permission for the PEM file. Chmod 400 with the PEM file name. Yes, that is completed. Then next one, let us use this SSH command, which is used to make a connection to the EC2 machine. Copy this example command, which is SSH connection we are making to the Linux machine. Then click on enter. It is asking, are you sure you want to connect? Yes, boss, I want to connect. Yes. So with this, I'm able to connect with my EC2 instance successfully. With which user account I have connected? I connected with the Ubuntu account. I have launched one Ubuntu EC2 instance, right? I connected to this machine as a Ubuntu user by using git bash. Once you are able to connect with this machine, then we need to execute these commands. Launch machine completed. Then install kubectl. Already we know what is kubectl, which is used to communicate with the Kubernetes control plane. So you need to copy this script and execute. Here there is an icon for copy. Just click on this icon. The script will be copied. Go to your git bash, right click, paste and enter. So this script, this is Linux script, which is going to install kubectl software in the Linux machine. So this kubectl software is used to connect with the Kubernetes cluster. Yes, with this, kubectl is installed with version 1.19.6, something like that. Then once the kubectl is installed, then second one, AWS CLI software we need to install. Let's copy this script also. Go to this git bash, right click, paste and execute. So with this, I'm installing AWS CLI software in the EC2 instance. Right. It is installing that software. Yep. AWS CLI is installed successfully. The version 2.15.44 version got installed. Then EKS CTL command we are installing here. So let us take this one, AWS EKS CTL script. Then go to the same Linux machine and execute this. Perfect. EKS CTL, which is used to create the cluster, guys. In order to create the EKS cluster, we are using EKS CTL. That is also installed. So with this, successfully we completed our first step. Then coming to the second step, in order to create the cluster by using this EC2 instance, for that EC2 instance, some permissions are required, guys. Those permissions we are going to provide by using IAM role in the AWS. By using IAM role, we are going to give that permission. Okay. So what permissions we need to give, I have given in the document. So let us see that a document, go to the IAM service in the AWS, create the role with the permissions and attach that IAM role with our EC2 instance. Step 2, create IAM role and attach to EKS management host. We need to create one IAM role and we need to attach that IAM role to our EC2 instance. Okay. So what are the permissions? IAM, VPC, EC2, CloudFormation, administrator. All these policies we will attach for the IAM role. Now go to our AWS account, search for IAM service. Go to IAM, Identity and Access Management. In the AWS cloud, to manage users, roles and policies, IAM service is available. Go to IAM, click on the roles. Already there are several roles available which are provided by the AWS. Now I will create our own role. Click on create role, AWS service, use case is EC2. I'm creating this role for the EC2 service. Click on next. Here, policies. What are the policies you want to attach for this role? So I have given the list of policies. One is IAM full access. So give IAM full access for this one. Go here, type IAM. You will get IAM full access. Select it. IAM full access. This is one policy I have selected. Then second one, VPC full access. Type VPC. Amazon VPC full access. Second policy also I have selected. Then third one, EC2 full access. EC2 full access. Then CloudFormation full access is required. That is the fourth permission. CloudFormation full access. AWS CloudFormation full access policy I have selected. And finally, I'm giving administrator access also. Fine. So with this total 5 policies we have selected for this role. Go to next. Then give the role name. I'm giving AWS EKS role. That's it. You can give any name for the role. Then click on create. You can check it. What all the policies you have selected. All the 5 policies we have selected. Finally, click on create role. With this one, IAM role is getting created. The role name I have given AWS EKS role. Fine. Once this role is created, then what is the next step that we need to follow? We need to attach that role to the EKS management host. Whatever the EC2 instance we have created, for that EC2 instance, we need to attach that role. How to do that role attachment, guys? Select the machine that you have created by using this checkbox. Then go to actions. Then go to security. Then modify IAM role. So select the machine that you have created. Then go to actions. Then go to security. Then go to modify IAM role. Here, you select the role that we have created. The role we created, that is AWS EKS role. Just now we have created this role. Select. Sir, why we are selecting this role? If you attach this role, then this EC2 machine will have the permission to create the cluster. Okay. Click on update IAM role. So with this, our step 2 also completed. Right. Then what is the third step, which is very important, guys? This is the final step, which is used to create the cluster in the AWS by using EKS. So create EKS cluster by using EKS CTL. EKS CTL software already we have installed in our EC2. Then we need to follow this syntax in order to create the cluster. So in which region you want to create the cluster, how many worker nodes you want for the cluster. Okay. So I want to create a cluster in the Mumbai region. Mumbai region code is AP South 1. And for the node, I want to use T2 medium instances. AP South 1A, 1B zones I want to use for that. If you want to create the cluster in any other region, then you need to change your region code and you need to change your availability zones. For North Virginia also, I have given the syntax. For Mumbai also, I have given the syntax. So currently, I connected with the AWS by using Mumbai region. You see, I'm operating my cloud services from the Mumbai region. So I'm going to use the command which is used to create the cluster in the Mumbai region. Now, currently instance is running only one instance is running, that is my host machine. By using this machine, I want to create the cluster. Now go to AWS, search for the service called EKS, Elastic Kubernetes service. This is the most trusted way to start, run and scale Kubernetes. go to EKS. When you go to the EKS, here you can observe what all the clusters available. Elastic Kubernetes Service, Amazon EKS, fully managed Kubernetes control plane. Okay. So this Kubernetes cluster that we are creating by using EKS, it is fully managed by AWS only. Go to the clusters here and you see currently, is there any cluster is available in the EKS service, guys? Currently, we don't have any clusters. Now I want to create the cluster. In order to create the cluster, this is the command. If you want to create the cluster in the North Virginia, you can use this command. If you want to create the cluster in the Mumbai, then you can use this command. I want to create the cluster in the Mumbai. This is the syntax, guys. In which region you want to create the cluster, what type of worker nodes you want to use, how many minimum worker nodes you want, how many maximum worker nodes you want. But in this command, I'm not giving the count of the worker nodes. If I don't give the count of the worker nodes, by default, it will take 2 worker nodes. One control plane, 2 worker nodes will be created. And remember this point, cluster creation will take 5 to 10 minutes of time. We have to wait for that. After cluster created, we can check our cluster is running or not by using this kubectl get nodes command. Once we are able to see the nodes which are available in the cluster, that means our cluster is ready. Okay, but immediately it will not be ready, guys. It will take 5 to 10 minutes of time to create the cluster. Okay, let me take this command. I'm giving the cluster name Ashok IT cluster 4. You can give any name for that. The region I'm giving as AP South 1, nothing but Mumbai region. The machines I'm using T2 media machines. The zones 1A, 1B availability zones I'm using. Take this command, copy this, then go here and execute. Sorry, I got disconnected from the machine. Let me connect back using SSH. Yes, I connected back to this machine, Ubuntu machine. Then paste this command, ekctl create cluster. Now the cluster creation process is started. Ashok IT cluster 4, EKS cluster creation started. Wait for the control plane to become ready. So by using this AWS EKS, my control plane is getting ready. So this Kubernetes cluster is deploying now. Now you go to AWS and you can check it. Okay, as of now the clusters are not available. So it will now you see error loading the cluster. Now the cluster is started, support period unknown. Ashok IT cluster 4, the status is creating. You need to remember this version. So if you say that I'm using AWS EKS cluster, in the interview they will ask you what is Kubernetes version you are using. We are using Kubernetes version 1.29. Okay, now the cluster creation started. This is a provider cluster, EKS provider cluster. The version 1.29, the status is creating. So inside this cluster, you can see what all the worker nodes available. Okay, so currently the nodes are not there. Still the cluster creation in progress. If you go to the compute node groups, how many worker nodes available in the cluster, you can check that. So currently the cluster is not ready. Once the cluster is ready, then we can see what all the nodes available, how many nodes available. So don't disturb this, guys. It will take time, 5 to 10 minutes of time it is going to take to create the cluster. We have to wait. Guys, successfully, I'm able to complete my cluster setup. Now you can see EKS cluster 4 in the Mumbai region is ready. My AWS cluster is created successfully. So how to verify my cluster is working as expected or not? So to verify whether our cluster is working as expected or not, we can use a command called kubectl get nodes command. So when I use kubectl get nodes command, now you can see that there are 2 worker nodes are ready and they are running from 2 minutes. The status is ready. So this my control plane is created. My control plane is created. For that control plane, there are 2 worker nodes associated already. So with this, my setup is ready. We are ready to deploy our applications in the Kubernetes cluster by using AWS EKS. Now, so once the cluster is ready, I want to deploy my application in the cluster. So let me go to Kubernetes architecture diagram so that it will be clear for us. Now, if you see in the Kubernetes architecture, we have control plane and we have worker nodes. Now I want to deploy my application by using this Kubernetes cluster. So to communicate with the Kubernetes cluster, we have installed kubectl. By using kubectl command, we can connect with the control plane and we can give the task to the control plane. Then control plane will assign the task to the worker node. Okay, so here already kubectl is available in the EC2 machine. I created one EC2 machine. By using this machine, we created the cluster. So when I execute kubectl get nodes command, it is displaying how many worker nodes available in the cluster. So currently here, there are 2 worker nodes available in the cluster. And let me check kubectl get to pods. How many pods are running in the cluster? Currently, there are no pods in the default namespace. So no application we have deployed. Currently, pods are not running in the cluster. Now, in order to deploy the application, we need to create the pod. Okay. Before going to understand the deployment part of the application, we need to know 2 concepts in the Kubernetes. Then only we can do the application deployment. First one, what is pod? The first concept that we need to learn in the Kubernetes, what is pod and how to create the pod. In the Kubernetes, guys, pod is a smallest building block that we can run in the Kubernetes cluster. If you want to deploy any application in the Kubernetes, for that application, you need to create a pod. There is no full form for the pod, guys. This is the name pod. Pod is a smallest building block that we can deploy in the Kubernetes cluster. So any application that you want to deploy in the Kubernetes cluster, for that you need to create the pod. Our application will be deployed in the Kubernetes cluster as a pod. Suppose if you want to deploy your application with multiple instances, then you need to create multiple pods for your application. For one application, we can create multiple pods also. Why we need to create multiple pods for one application? If you create multiple pods for one application, high availability will be there. If one pod is deleted also, if one pod crashed, if one pod is damaged, then no problem, other pod will be available to execute our application. That is the reason in the real time, for every application, multiple pods will be created. Pod is a smallest building block that we can deploy in the Kubernetes cluster. Our application will be deployed in the Kubernetes cluster as a pod only. For one application, we can create multiple pod replicas for the high availability. And whenever you create a pod, for every pod, one IP address will be generated. For every pod, one IP address will be generated in order to access. And here, if any pod is damaged or if any pod is crashed, then Kubernetes will replace that pod. That concept is called self-healing. That concept is called self-healing. Okay, guys. If Kubernetes pod is damaged, then it is going to replace the pod. Guys, are you clear with my point? What is the pod and why we need to go for the pod? Pod is the smallest building block that we can deploy in the Kubernetes cluster. Our application deployment will happen by using pod only. For one application, we can create multiple pod replicas for the high availability. For every pod, one IP address will be generated. If a pod is damaged or if a pod is crashed, then Kubernetes will replace that pod for the self-healing process. Okay, next one. Here, to create the pods, we are going to write manifest YAML. I want to create the pod. To create the pod, we are going to use a YAML file. That YAML file are called as manifest YAML file. Okay, within the YAML, we will specify what pod we need to create, by using which Docker image you want to create the pod, how many containers you want to create in the pod, what is the pod label, all that information we are going to specify in the manifest YAML. And another thing is, whenever you send a request to the control plane to create the pod, by using, I will write one YAML file. In that YAML file, I will declare my pod manifest and I will execute that YAML by using kubectl. Then control plane will take my request. Control plane will assign the task to the worker node. Inside the worker node, my pod will be created. When the pod is created in the worker node, we cannot access the pod directly, guys. Okay, so I will write one manifest YAML. That manifest YAML, I will execute by using kubectl. then the pod will be created inside the worker node. So kubectl is used to communicate with the control plane. I will assign the task to control plane. Control plane will assign the task to worker node. Inside the worker node, our pod will be created. By default, pods are accessible only within the cluster. You can't access the pod outside. That means you can't access your application directly if you create only pod for that. Then what we need to do to expose the pod outside the cluster, we need to implement a concept called service concept. First, we need to create the pod. Once the pods are created, those pods we need to expose. Those pods we need to expose by using services concept. Are you guys able to follow me? First, we need to create the pod. By default, pods are accessible only within the cluster. If you want to access the pods outside the cluster, then we need to use service concept in the Kubernetes. Okay. Are you guys clear with what is pod in the Kubernetes? Pod is a smallest building block that we can deploy in the Kubernetes cluster. So if you see in our application, we need to create the pods. So using kubectl, I will connect with the control plane. By using the kubectl, I will execute my YAML. In that YAML, I will specify the configuration to create the pod, which Docker image it has to use to create the pod, what is the name of the pod, what is the label of the pod, everything we are going to specify in the YAML. That YAML I will execute by using control plane. Then that control plane will assign the task to the worker node. There are 2 worker nodes available. So in any worker node, it can create the pod. So pod is the smallest building block that we can deploy in the cluster. So if you want to deploy your application deployment in the Kubernetes means creating the pod only. For one application, you can create multiple pods. What is the benefit of creating multiple pods? High availability will be available. Suppose I created 3 pods. One pod got deleted. No problem. Kubernetes will replace that pod with the another pod. Self-healing will be available for the pods. Okay. Then here for every application, multiple pods will be available. So whenever you create the pod, outside you cannot access the pod. So pods we can access only within the cluster. Sir, how can we access the application running in the pod in our system? Then whatever the pods are created, those pods we need to expose by using a service concept in the Kubernetes. So are you guys clear with what is pod? Are you guys clear with the concept of what is pod in the Kubernetes? Pod represents runtime instance of our application. Pod represents runtime instance of our application. If you want to deploy any application, then that will be deployed by using pods only. If you want to deploy any application, the application will be deployed by using pods only. Pod is a smallest building block that we can deploy in the Kubernetes cluster. How to expose the pods? In order to expose the pods, we are going to use a concept called service concept. Okay, what is a service in the Kubernetes? Kubernetes service is used to expose the pods. Whatever the pods we have, in order to expose the pods, we are using service concept. Okay, in the Kubernetes, there are 3 types of services available. In the Kubernetes, there are 3 types of services available. What are those 3 types of services? First one is called cluster IP. Okay, whatever the pods we have created in the worker node, all the pods we can expose by using one IP address. For every pod, a separate IP will be available. But for all the pods, I want to give one single IP for the load balancing. So if you want to expose all the pods by using single IP, then you can use cluster IP. But cluster IP is used to map. Every pod will have its own IP. Every pod will have its own IP. But all the pods I want to access by using single IP address for the load balancing purpose. Then you can go for cluster IP. If you use the cluster IP, the pods will be exposed only within the cluster, but not outside. Okay. Suppose, for example, when we are going to deploy the database in the Kubernetes cluster, then database, I don't want outside people to access my database. Then the database I will expose by using cluster IP. For database, I will create 3 pods. For 3 pods, I want to give the single IP address. But those database pods should be accessed only within the cluster, not outside the cluster. Then we can give cluster IP service. We can use cluster IP service to expose the database pods. For example, I'm deploying my application. I want to access my application outside of the cluster. Then there is a service type called node port. So node port is a service which is used to expose the pods which are running in the particular worker node. Now there are two worker nodes available. My pods are created in the both worker nodes. I want to create 4 pods for my application. 2 pods created in the first worker node, 2 pods created in the second worker node. So which worker node pods you want to access outside, that you can expose by using node port. Okay, so if you want to expose your pods for access, we need to use a service concept in the Kubernetes. So in the Kubernetes, there are 3 types of services available. One is called cluster IP, which is used to access the pods within the cluster only, within the cluster, not for outside the cluster. If you want to access the pods outside the cluster, then there is a service type called node port is available. When you go for node port, you can access the pods which are running in the particular worker node. Okay, but if you want to access the pods running in all the worker nodes in the load balancing mechanism, then the service type is available as a load balancer. My application is having 10 pods, 5 pods running in one worker node, remaining 5 pods running in another worker node. Okay, then if you want to access all the pods with the load balancing technique, then we need to expose those pods by using a concept called load balancer. These 3 are called as services in the Kubernetes. First, we need to create a pod, and those pods we are going to expose by using service concept. Kubernetes service is used to expose the pods. We have 3 types of services in the Kubernetes. One is the cluster IP, second one is node port, and the third one is load balancer. Are you guys clear? Are you guys clear with what is pod and what is a service? Are you guys clear with what is pod and what is the service? Pod is a smallest building block that is used to run our application. If you want to deploy your project in the Kubernetes, then you need to create the pod only. To create the pod, we will write the YAML file. To create the pods, we are going to write the YAML file. Okay, once the pod is created, IP will be generated. Can we access the pods outside the cluster? We cannot access the pods outside the cluster. We cannot access the pod outside the cluster. Then how to expose the pods to access outside of the cluster? By using service. Service is used to expose the pods. How many types of services available in the Kubernetes? How many types of services available in the Kubernetes, guys? There are 3 types of services available in the Kubernetes. What are those 3 types of services in the Kubernetes? One is cluster IP, second one is node port, third one is load balancer. What is the meaning of a cluster IP? Cluster IP is used to access the pods within the cluster. Okay, so if you are deploying the database in the Kubernetes, database pods we don't expose for outside people. Database pods we will access only within the application, within the cluster. So any database if you are deploying in the Kubernetes, database pods we will expose by using cluster IP within the cluster. Suppose if you are deploying the application pods we can expose by using node port and load balancer. What is the difference between node port and load balancer? Can you guys respond? What is the difference between node port and load balancer? Can you tell me the difference between node port and load balancer? What is the difference between node port and load balancer? Node port is used to access the pods belongs to particular worker node. Okay, node port is used to access the pods belongs to particular worker node. If you want to access the pods belongs to all the worker nodes, then which service? Load balancer service we are going to use. Are you clear with my point? Are you guys clear with my point? Are you guys clear with my point? Now, I want to create the Kubernetes manifest YML to create the pod and expose the pods by using service concept. So when you are going to write the Kubernetes manifest YML, we need to follow some syntax. Okay, guys? Kubernetes manifest YML syntax. Manifest YML, it will start with 3 hyphens, end with 3 dots. Okay, let me save these notes for time being. All right. Now, Kubernetes manifest YML I want to write. So what sections we need to write in the YML file? In this YML file, 4 sections will be available. One is called API version. Okay. Second one is kind. Third one is metadata. Fourth one is spec. These are the 4 sections we are going to keep in our manifest YML. So API version and kind, metadata, specification. So in the Kubernetes manifest YML, we need to write these 4 sections in order to create the pod, in order to create the service. Okay. Now, when I want to create the pod by using this manifest YML, what is the configuration we need to write in the YML? Observe carefully, guys. First time, it may be a little bit confusion for you, but if you practice, then you can understand how to write this manifest YML files. Okay, when you are going to write the manifest YML file, I'm going to write a manifest YML file to create the pod and the service. I want to create the pod and I want to expose the pod by using service concept in the Kubernetes. Okay, so to create the pod, API version, I'm going to specify apps/v1. Sir, what API version we want to use? That we can identify in the official Kubernetes documentation. Okay, I want to deploy my application by using Kubernetes cluster. I want to create the pods and I want to expose the pods by using a service concept. API version apps/v1. Kind, what you want to do? I want to create one deployment in the Kubernetes. Kind is a deployment. API version apps/v1. Kind is a deployment. Kind deployment means I want to create one deployment in the Kubernetes. I want to deploy my application. Metadata. For this deployment, can you give some name? Yes, I'm giving some name for the deployment, which is Java web application deployment. Okay. What deployment you are creating in the Kubernetes? For the deployment, you give some name by using metadata. Then coming to the spec, how many pods you want to create for this deployment? Replicas 2. I want to create 2 replicas. That means I want to create 2 pods. If you give 5, then 5 pods will be created for your application. Why we need to create multiple pods for our application, guys? What is the reason for creating multiple pods for our application? For a high availability. If any one pod is deleted, then remaining pods are going to allow the traffic. That means the load balancing will happen, load distribution will happen when you create multiple pods. To achieve high availability, we are going to create multiple pods. And what is your deployment strategy? So there are multiple strategies available. I'm using rolling update. I'm using a strategy called rolling update strategy for that. Then deployment strategy type is a rolling update. Deployment strategy is rolling update, right? So I want to create a pod. API version apps/v1. Kind is a deployment. Metadata name is Java web application deployment. Under the specification, we are giving 2 replicas, and the deployment strategy we are going to follow as rolling update strategy. Recreate, rolling update, canary. There are 3 strategies available. Currently, I'm using one strategy called rolling update. Then next one, here we are going to specify selector. That means labels we are going to give for the pod. So selector, match labels. What is your pod label? For the pod labels, I'm giving the label name as app Java web. So this selector is going to represent pod label. That means which pod you want to deploy. Which pod you want to deploy, that we are specifying by using match label. My pod label name will be Java Web App. Once it is completed, then we need to create the pod template. As of now, we have taken deployment manifest. Now, pod template we need to specify. In the pod template, we are going to specify metadata. What is the metadata? The pod name. You can give any name for the pod. I'm giving the name as Java Web Application Pod. I'm going to deploy one Java Web Application by using pod. So the pod name I am giving as Java Web Application Pod. And for the pod, I'm giving labels. The label name is Java Web App. And remember, whatever the label name you are giving for the pod, same label name we are going to specify as a selector. Kubernetes deployment should create the pods and should follow the deployment strategy. So this is the pod template. For this pod template, I'm giving a label name. This label name we need to configure as a selector. Then once the label is configured, then specification for the pod. Okay. So what is your pod specification? That means where is your Docker image to create this pod? So the Docker image information will specify by using specification. So inside the pod, what container you want to create? Inside the specification, I'm specifying my containers information, container name. I'm giving the name as Java Web Application Container. To create this container, I need to give the Docker image. My Docker image is available in the Docker Hub. The Docker image name is ashokit/Java Web App. So this is my Docker image for the application. Already this Docker image is available in my Docker Hub account. So by using this Docker image, this container will be created inside the pod, and for that pod, 2 replicas will be created. And this container is going to run on the port number. Ports will be available. The ports, container port. This is a Java application which will run on the Tomcat server with the port number 8080. With the port number 8080. This is a manifest YAML which is used to create the pods for my application. Okay, so there are mainly 4 sections available: API version, kind, metadata, and spec is available. API version is apps/v1, and I want to create a deployment. For this deployment, I am giving some name as a Java Web Application Deployment. How many pods you want to create? I want to create 2 pods, so 2 replicas I want to create. Strategy, I want to go for rolling update strategy. And which pods you want to expose by using this deployment? Here pod template is available. In the pod template, I'm giving the name for the pod template, pod name, and pod label. Labels and selectors are very important. Label is nothing but the ID for the pod. Label is used to identify the pod. This pod label is app Java Web App. You can give any name for the label. Label is like an ID card. So with this label, it will identify that by using selector. And inside the pod, what container you want to create? I want to create a Java Web Application Container inside the pod. This is the name for the container, and this is the image for the container. And ports, container port I am giving as 88. So this is called as our pod manifest YAML. This is called as our pod manifest YAML. By using this pod, we are deploying our application. Okay. So now, if you create this, can you access this application outside? Can we access these pods outside the cluster, guys? If you create the pod now. If you create the pod now, can we access these pods outside the cluster, or we cannot access the pods outside the cluster? Can we create these pods outside the cluster? Can we access these pods outside the cluster? We cannot access the pods outside the cluster. We cannot access the pods outside the cluster. So what I need to do to access these pods outside the cluster? What I need to do to access the pods outside the cluster? We need to expose by using service concept. So what services available in the Kubernetes? Cluster IP, node port, cluster IP, node port, and cluster IP, node port, and load balancer is available. Cluster IP means within the cluster only we can access. Node port means particular worker node IP we will use to access the pods. Load balancer, which will give you the access for all the pods available in all the worker nodes by using load balancing technique. Now, so we need to expose the pods. We need to expose the pods. To expose the pods, we need to create the service. To expose the pods, we need to create the service concept. Are you getting my point? In order to expose the pods, we need to create the service concept. So for the service, again, manifest we have to write. So API version, service manifest you can write separately or you can write in the same also. Kind, metadata, and spec will be available. 3 sections, 4 sections will be available. So this is our deployment manifest to deploy the application by using pod. And these pods we need to expose. For that, we are going to write the service. API version, kind, metadata, and spec. API version, we are going to give this as V1 for the service. Kind. Kind represents what you want to create. What you want to create by using kind section service. What we want to create is that the service that we need to specify. And metadata. What is the name you want to give for the service? I want to give the name as Java Web App Service. I want to give the name as Java Web App Service. Okay, guys. Then next one, spec. Spec means specification of the service. What is the service type? I want to specify the service type as load balancer. I want to expose these pods by using a service called load balancer service. Okay, so when you specify type as a load balancer, then the pods will be exposed as load balancer service. Which pods you want to expose by using load balancer? Selector. Selector will represent pod label. The pod label is Java web application. This is the label. So these are the pods. This is pod template. This is used to represent our pod template. So I want to create a container inside the pod by using this Docker image. For this pod, I am giving the label as app::Java web app. Okay, so these pods I am exposing by using a service called load balancer type. So this service should identify which pods it has to expose. That's why the pod label we are configuring as a service selector. Pod label we are configuring as a service selector. Then after this one, port mapping. So our application will be running on the port number 8080. I want to map this to the port number 80. The container is running on the port number 8080 and load balancer port I want to map to 80. This is port mapping, which is used to access our pods by using load balancer service. Okay, so this is our manifest YML, guys. This is our manifest YML. This is used to create the pod. I want to create the 2 pods for the application and the pods having the label. This pods should be created by using which Docker image. The Docker image name also I am specifying here. Once these pods are created, the pod label is available. By using this pod label, we are exposing the pods by using load balancer service. Writing this manifest YML requires a lot of practice. So this is a workshop. So I'm not focusing on butifying this YML file for you now, guys. So I will show you how to create the deployment, how to expose the pods, how to access the pods. In the Kubernetes class, as I told you, Kubernetes course will take 2 weeks of time, right? In that 2 weeks of time, you are going to learn this concept only. How to write the pod manifest YMLs, how to create the services by using YML, how to create the namespaces by using YML, how to create blue-green deployment by using YML. The 2 weeks of time I told you for the Kubernetes course, right? In the 2 weeks of time, we are going to learn this YML. As it is a workshop, I can't spend that much amount of time here to deal with all these things. Okay, so I will give you this YML file in order to create the deployment. After this workshop, you need to focus on how to write these YML files. Okay, it requires some practice, guys. Within 1 hour, within 2 hours, you can't understand these YMLs. So it may take 1 week to 10 days of time to understand how to write these YMLs. So Kubernetes course means they will tell you how to write these YMLs. Now, once this YML file is available, once this YML file is available, then you can go and create the deployment and you can access them by using this manifest YML. Okay. So look at this YML. Just read that YML from top to bottom once. Look at the YML from top to bottom once. Just for our understanding purpose. Strategy rolling update, recreate option will be available. Rolling update means when you are redeploying the application, it will create the old pods and it will delete the old pods and it will create the new pods. That is rolling update. There are three strategies available in the deployment: rolling update, recreate, and canary. Rolling update is available, recreate strategy is available, and the canary strategy is available. Indentation is very important. You need to follow the indentation. This is a YML, or we can say YAML. Indentation is very, very important when you are writing these YMLs. You need to follow the indentation. So this first section will represent a deployment for the pod. Second section will represent a service for the pod. Now, whatever the YML file we have, that YML file we need to create in our machine. Okay, let me connect with this machine. Now, in this machine, we will create this YML. In this machine, we'll create the YML ls-l. So currently, there is no YML file available. I'm going to create the YML to deploy my application. Deployment.yml. So vi java web app deployment.yml. This is called our Kubernetes manifest YML. I'm keeping our manifest YML here. So this is deployment section and this is my service section. Both are available in this YML, and the service type I'm using as load balancer. So I'm going to specify replicas to 2. So 2 pods will be created. Those 2 pods we are going to expose by using load balancer service. All right. So with this, my YML file is ready. With this, my YML file is ready. Once the YML file is ready, then we need to create the pods. Okay. How we will create the pods now? We need to execute kubectl commands. So observe carefully, my YML file is ready. So now, before going to see this execution, can you see, is there any load balancer available in the EC2? We have used service type as a load balancer. Is there any load balancer created in my AWS account? Currently, load balancer is available. Currently, load balancer is not available. Currently, no load balancers available. When you execute this YML, we have created service type as a load balancer. So it is going to create one load balancer. It is going to create one load balancer to access our pods. Let me execute first. kubectl get pods. Any pods available? No pods available. kubectl get service. Any services available? No service is available. One service, that is the default Kubernetes service available. Our application service is available, or our application service is not available. For our application, one service is available or not available? No. Currently, no pods available. Currently, no services also available. And any deployment is available. Any deployment is created. Kubernetes get deployment. Now, before executing my YML, I'm checking what are the pods available, what are the services available, what are the deployments available. So here, currently no pods available, no services available, no deployments available. Now, I want to execute this YML file. So before executing this YML, I'm using a command called kubectl get pods command. What is the purpose of get pods? To see what all the pods available in the cluster. Now, I want to see what all the services available. kubectl get service. This is going to display what services you have created in the Kubernetes cluster. If you want to see what deployments you have created in the Kubernetes cluster, we will use kubectl get deployment. I have executed 3 commands. I'm not able to see any pod. I'm not able to see any service. I'm not able to see any deployment. Okay. Now, so what is this command purpose? kubectl get pods command. This is used to check the pods which are running. What is the purpose of get service? It is used to check services running. Check services running. And kubectl get deployment. Check deployments created. Check deployments created. Check services created. Check pods running. Okay. If you want to see what all the pods running in the Kubernetes, then you can use kubectl get pods command. What is a kubectl? Kubectl is a command line utility which is used to communicate with the Kubernetes cluster and check what all the pods running. kubectl get service. It is used to check what all the services created. kubectl get deployment. What deployment is created, I want to check that. Okay, suppose if you want to see the pods running in the which worker node, okay, check pods running in which worker node. So two pods. So these are two pods created in first worker node or in the second worker node. I want to check the pods running in which worker node. For that, kubectl get pods -o wide. If you use -o wide, then that will display your pods are running in which worker node. Okay, so two pods I have given, right? Those two pods are running in the first worker node. Those two pods are running in the second worker node. We can check that by using -o wide option. Then how to create the deployment? How to execute the YAML? In order to execute the YAML, okay, execute Kubernetes manifest YAML. Execute Kubernetes manifest YAML. To do that, we will use a command called kubectl apply -f our YAML file. Okay, kubectl apply command we are using to execute that YAML. kubectl apply -f YAML. So with this, that YAML file will be executed. So in this YAML, what we have given? We have given a deployment, we have given pod template, and we have given service. So pods will be created, deployment will be created, service will be created. Service type we have given as a load balancer. So as the service type is a load balancer, in the AWS, one load balancer will be created. We are using AWS EKS cluster. So when you use service type as a load balancer, the load balancer will be created in the AWS. Using that load balancer URL, we can access our application. Okay, so look at the commands that we are going to execute. kubectl get pods. What is the purpose of kubectl get pods command? kubectl get pods command will show you what all the pods running in the cluster. kubectl get pods -o wide, which is used to display the pods running in which worker node. kubectl get service. Which service you created to expose the pods, we can check it. kubectl get deployment. So you need to deploy your application by creating the pods. What is the deployment that you can see? How to execute this Kubernetes YAML? In order to execute this Kubernetes YAML, kubectl apply -f YAML file. Okay, so if you use kubectl apply -f YAML, then the YAML file will be executed. In that YAML, whatever the resources you configured, those resources will be created in the Kubernetes cluster. Are you guys clear with the commands now? Can we execute this and can we see our application is deploying in the Kubernetes or not? Yeah. My YAML file is already available in this machine. Now, let me go and execute it. Okay. I got disconnected from the machine. Connect back. I connected back to my machine. In this machine, I have the cluster access. By using this machine, kubectl command, I can communicate with my Kubernetes cluster, guys. Okay. So in this machine, kubectl is available. Using that kubectl, I can communicate with my Kubernetes cluster. Now, I connected to my EC2 machine. In that machine, my kubectl is available. Using the kubectl, I will communicate with the control plane. Control plane will communicate with the worker node. Control plane is going to communicate with the worker node. Inside the worker node, pods will be created. In which worker node pod will be created, that will be decided by the control plane. In which worker node pod will be created, that will be decided by the worker node. and those pods we are exposing by using service. All right. Good. Now check the pods again. kubectl get pods not available. Then check again. kubectl get service. Application service is not available. kubectl get deployment. kubectl get deployment. Deployment is also not available. Okay, no pods, no services, no deployments. Now I need to execute my YAML. So my YAML file is already available in this machine, Java web app deployment.yml. We need to apply this YAML. How to apply this YAML? kubectl apply -f file name. File name can be anything. There is no naming convention for the file. So my file name is Java web app deployment.yml. kubectl apply -f this web app deployment.yml. Now you can see the YAML file is executed successfully. My deployment is created. My service also created. The application deployment is created and application service also created. Nothing but my pods are created. My pods are exposed by using service. So when we are writing this YAML, we should be careful. The spacing, the indent spacing is also very, very important. If you do a small mistake with the space also, the deployment will not be created. So we have written the perfect YAML and we are able to execute that YAML by using kubectl apply command. My deployment is created. My service is also created. Okay. Then how to check it? Is it really created or not? Now go for kubectl get pods. Now you can see there are 2 pods created and those 2 pods are in the running status now. kubectl get pods. So 2 pods created. This is the name of the first pod and this is the name of the second pod. They are in the ready state and they are in the running. From 48 seconds, those pods are running. So with this, we are able to see the pods status. kubectl get pods, 2 pods are running. In which worker node those pods are created? -o void. Okay. Now it will display the pods are running. See, this is the pod IP and where these pods are running, you can see the node IP also. So in which worker node those pods are running, node IP is also printed. So this is running in the 192.168.21.176 and this is running in 192.168.117. So that means 2 pods are running in 2 different worker nodes. So I have given pod count as 2 pods created in 2 different worker nodes. How we are able to see the pods are running? This is pod IP. This is pod IP. This is pod IP. 2 pods are running. Node IP. This is the first pod node in which worker node it is running. This is the second pod node IP in which worker node. So this is running in 176 node IP. This is running in 117 node IP. You can go to our EC2 dashboard and you can see the instances. There are 2 worker nodes are running. Select this worker node. Node IP is available. Okay. And this is the second worker node IP is available. 176 IP is available. And 117 IP is available. One pod is running in 117 IP and the second pod is running in 176 IP. So 2 pods are running in 2 different worker nodes. Who created those pods in the worker nodes? I have created, or my control plane will decide that? I have created, or my control plane will decide that? I have given the task to control plane. Control plane has assigned the task to worker node. Those pods are created in the worker node. I have given pod count as 2. So 2 pods are created in 2 worker nodes. And check the service here, whether the Kubernetes service is created or not. kubectl get service command. kubectl get service. Yes, one service is available. That is the Java web application service is available. Service type is a load balancer. This is the load balancer URL in order to access our application. Now go to AWS load balancer section. Earlier 0 load balancers available. Now you see one load balancer is created in the AWS. Now refresh the load balancer section. One load balancer is created. Then click on this load balancer. For the load balancer, DNS will be available. This is the DNS name of the load balancer. By using this DNS name, we can access our application. Okay, hit this URL, the application load balancer is created. Okay, now you can check the deployment also. kubectl get a deployment. What is the deployment created? How many pods created in the deployment? So deployment is created. I told to create the 2 pods in the deployment, 2 replicas created, and they are available and they are up to date, they are running. My deployment is ready. Now, if you want to undeploy the application, you need to delete the deployment. If you delete the deployment, your pods will be deleted, your services also going to be, your pods will be deleted basically, right? So 2 pods are running on the deployment. These 2 pods are running in the each worker node. Now, how to access our application? Load balancer service is available. Take this load balancer DNS, go to the browser. My application context path is java-web-app. So with this, I'm trying to access my application, which is running in the Kubernetes cluster. Right, perfect. I'm able to access my application. So let me give this URL. You can hit this URL, then you can see my application which is running in the Kubernetes cluster. I have deployed my application. I have created the pods. Those pods I have exposed by using load balancer service. By using that load balancer URL, I'm able to access my project. Any application you can deploy. The only difference, guys, if you want to deploy any other application, the only difference, the image name is going to be different. Okay. So now I am using this Ashok IT/Java web app image that we have deployed. If you want to deploy another application, then you need to change the image. Where is the Tomcat? Where is the code? Everything is part of this Docker image. In the Docker image, our code plus dependencies plus servers, everything will be available in the Docker image. We are taking the Docker image and we are creating the deployment. That's it. Sir, where is Tomcat? Where is Java? Where is code? Everything will be available in the Docker image. So that's why if you know the Docker, then easily you can understand the Kubernetes. Docker is prerequisite to understand the Kubernetes. Fine. Now we are able to create the deployment in the Kubernetes. So we have created several resources in the Kubernetes deployment now. So what all the resources that you have created? If you want to get all those details, then you can use a command called kubectl get all command. Kubectl get all command will be available. That will give you all the resources that we have created by using Kubernetes. All the resources that you have created by using Kubernetes, you can get this information. Kubectl get all. We have created 2 pods. We have created 1 service. We have created 1 deployment. Okay. If you want to delete all these things, then you need to use a command called kubectl delete all -all. Then everything will be deleted. Can we see one of the concept called self-healing? As I told you, Kubernetes will provide you self-healing. What is the meaning of Kubernetes self-healing? If any one pod is deleted, Kubernetes will recreate that. Can we check it? Can we prove that practically? Is Kubernetes providing self-healing or not? There are 2 pods running. I will delete 1 pod and I will see the behavior of the Kubernetes. I will delete 1 pod and I will see the behavior of the Kubernetes. Okay. Now observe. You can see the count kubectl get pods. There are 2 pods running. Now these 2 pods, you can see age of the pods. From the last 15 minutes, these 2 pods are running. Kubectl get pods command. From the last 15 minutes, these 2 pods are running. Now what I want to do is delete it. Kubectl delete 1 pod. I'm giving pod ID. Kubectl delete pod with the pod name. Kubectl delete pod with the pod name. Now pod is deleted. So now you see earlier there are 2 pods available. Those 2 pods are running from the 15 minutes. Now I have deleted 1 pod by using kubectl delete pod name. Now check the pods count. Get pods. Again 2 pods are available. So 1 pod is running from 16 minutes. Another pod is running from 18 seconds. That means Kubernetes recreated the pod. Is a self-healing available? Is a self-healing available in the Kubernetes or not? if any one pod is deleted, another pod it created. High availability. So I have given the replicas as 2. So always 2 pods will be maintained. If one pod is deleted, then it is creating another pod that is called self-healing. Kubernetes is having self-healing. Are you able to prove that Kubernetes is having self-healing? If both pods deleted, and then again 2 pods will be created. If both pods are deleted, another 2 pods will be created. Okay. It no need to identify which pod is deleted. If one pod is deleted, another pod will be created. That's it. If one pod is deleted, then another pod will be created. That is called self-healing. Self-healing, nothing but if any one pod is deleted, then it will create the another pod for that. Now let me do that once again. Let me check the kubectl get pods command. Yeah, one pod is running from 17 minutes, another pod is running from 97 seconds. Let me delete the old pod. How to delete it? Kubectl delete pod name. Select it. If you select it, it will be copied. Then paste it. Delete that pod also. Old pod, which is running from 17 minutes, I have deleted. Then check the pods immediately. Another pod came. 5 seconds ago, one more pod got created. So if you delete one pod, Kubernetes is creating another pod. That is called self-healing. This is one of the biggest advantages in the Kubernetes. High availability will be there for our application. Now, I want to check the logs of the pod. Kubectl logs give the pod name. Then you can paste it. Kubectl logs of the pod. It will display how your application is executing. Your pod logs will be printed. If any pod is damaged, if any pod is crashed, if any problem occurred in the pod, how can we check the logs of the pod? By using kubectl logs command, you can check the logs of the pod. In the interview, they will ask this question also. My pod is having some problem. How do you troubleshoot that problem? By checking the logs of the pod. How to check the logs of the pod? To check the logs of the pod, we will use kubectl logs command with the pod name. So this is the pod log. It is going to display how our application is started. This is my Spring Boot application. This Spring Boot application is running in the Tomcat server with the port number 8080. So internally, it is using Tomcat server to run our application. That Tomcat server running on the port number 8080, that 8080 port number is called as our container port number. Whatever the 8080 port is available, that 8080 port is called as our container port number. Are you guys clear with my point? Okay. Now, next, I want to do the deletion. I want to delete everything which I have created. To delete everything which we have created, kubectl delete all all the resources will be deleted. My pods are deleted, my services are deleted, my deployment also getting deleted. If you want to clean up the cluster, then you can use this command kubectl delete all all. What are the resources that we have created in the cluster? If you want to delete all these resources, then you can use kubectl delete all all. So whatever the deployment is created, the deployment got deleted. Whatever the deployment is created, the deployment got deleted. Are you clear with my point? Are you clear with my point? Okay. Now, whatever the deployment that we are doing manually, we are executing kubectl command manually. But in the real time, the deployment will be created by using a CI/CD pipeline like this. Okay. We are going to create one CI/CD pipeline by using Jenkins. So when we run this Jenkins pipeline, then what will happen? Jenkins will take the code from the Git repository. Jenkins will build that code by using Maven. Jenkins will create a Docker image for the application. Then finally, that Docker image will be deployed in the Kubernetes cluster. This is our Jenkins CI/CD pipeline. Developers will be available for the project. Developers will write the code and they will push that code to the Git repository. Then the Jenkins pipeline will trigger. The Jenkins pipeline will take the code from the Git repository. Then Jenkins will build the code by communicating with the Maven. Code compilation, code packaging will happen by using Maven. Once the code is packaged as a jar file or war file, then Jenkins will communicate with the Docker. It will create the Docker image for the application. That Docker image we are going to configure in our Kubernetes manifest file. This is the Docker image. Once the Docker image is created, then Kubernetes deployment will happen by using that Docker image. This is called CI/CD pipeline. So in the real time, the project deployment will happen with this CI/CD pipeline. Docker image creation, Kubernetes deployment will happen. Okay, guys. Here, so if you know this is Jenkins, Docker, and Kubernetes, then you can build this CI/CD pipelines. So in the real time, DevOps engineers are responsible to create this CI/CD pipeline. DevOps engineers are responsible to build these Docker images. DevOps engineers are responsible to create the Kubernetes manifest file and create the deployment of the application. As a developer, you should also have some idea what is the CI/CD pipeline, how Kubernetes deployment will happen, how to check the logs in the Kubernetes, how to check the pods in the Kubernetes, what is the Kubernetes manifest YAML, what is pod, what is service, how many types of services available. This idea should be there for the developers also. Nowadays, for the developers also, they are asking the questions related to DevOps tools. How to create CI/CD pipeline by using Jenkins, how to build a Docker image by using this Docker, how to deploy the Docker image by using Kubernetes, what is Kubernetes cluster, everything.